I'm having some.
Looks like we might be having some internet issues. Is it a little choppy, Vinay? Hey, Tim.
Hello.
Good to see you.
Yep, good to see you. Is now a good time to tell you that I can't present today? Is that a good time?
Now's not. Now's if that's true, then now is the best time to tell us.
Yeah.
As opposed to later.
As opposed to later, yeah. Yeah, that's what I thought. I was just checking. It's been such a long time since I've done my slides. I had to go over them again. I've just been such a while here.
Yeah. Well, good. Yeah, we the webinar is live, ready for people to join. So
Okay.
a few people signing on. And for those who are signing on, I'll say hello. Thank you for joining. We'll wait a few more minutes, of course, till at least the top of the hour. Maybe we'll wait till a minute after 2 or something like that. But it's good to see folks ready. Hopefully the weather is as beautiful for everyone as it is outside the academic buildings of Clemson University right now. I almost didn't make it back in for the webinar because I was sitting outside enjoying the sunshine and the 75 degrees or something like that in December. Gotta love that. Hopefully Christmas Day will be a little colder though, right? To get us in the right holiday spirit.
It makes you want to have a convertible, doesn't it?
Yeah. And again, for those who have just signed on, welcome. We're all sort of gathering in the room here, ready to get the webinar started a little after the top of the hour. Thank you for joining us today. Okay, 2 o'clock now, so we will wait one more minute though, at least. Thank you all for joining, signing on. Hopefully everyone can hear okay. The chat is certainly open if you have comments you want to make or questions during the seminar or during the webinar. Feel free to put those in the chat or whatever. I see our full team is on and ready to go, so we're excited to hold this one. Okay, everybody. Thank you for jumping on. My name is David Ladner, and I'm an associate professor at Clemson University. And I am here with Dr. Beth Caraway and Dr. Michael Carvajales Dale. We are co-collaborators or co-principal investigators on a project funded by the Environmental Protection Agency. And we developed a program called SCE3, South Carolina Energy Economy Environment. And that's the little logo behind me or in my virtual background. The SCE3 program is all about reducing pollution, reducing energy, and helping businesses be more economical and more streamlined in the way they do their business. And it's a win-win type of program. We're here today to talk about one way that we can reduce energy, and that's through lighting. And before I get to that, I did want to also introduce our two graduate students, Yas Srivastava and Danielle Larson, who are working with us on this program. We appreciate them being here, and they've done a lot of the legwork to get everything set up today. Our speakers today, we think this is going to be a unique webinar because we have three speakers who are not talking about totally separate items, but they're all aligned together. So we have Vinay Mehta, who represents the manufacturers of lighting and components. We have Daniel Hancock, who represents a contractor and an installer. If someone wanted to do a lighting project, he would be the guy that you would interface with probably most directly. And then we have Tim Howard, who represents a client or someone who uses a lot of this new technology that we have available to us. So without further ado, we're going to go in that order. I'm going to pass it over to Vinay, who will share his screen and give us his part of today's presentation. Vinay?
Thank you. Can you hear me?
Yes.
Great, great. I'm going to just get my screen share going. Share, and we'll get this into Can you see everything okay?
We can, but we do see the presenter view, not the presented view.
Okay, let me just adjust
Maybe
that.
in those display settings at the top, you can say switch presenter and
Yes. Is that better?
That's perfect. All right.
Great, great. Thank you so much. Thank you, David. Thank you to SCE3 for this opportunity to speak today. And also thank you to my esteemed cohorts in the energy industry. I'll be the first of 3 presentations, like David mentioned. And this is from the manufacturer perspective. And welcome to the LED lighting revolution, a win for climate, economy, and society. So a little bit about myself. I've been in the lighting industry for 11 years now. I joined Signify right out of college, and I've had a number of roles in sales, marketing, and supply chain, which is a big one right now. And I thought I'd start kicking off with a personal anecdote. There's a photo on the right-hand side, which is a photo of Bangladesh. And about myself, I'm married and my wife is Bangladeshi. And as you can see in this photo, this is a photo I took when we were traveling there. You can see that there's, quite a bit of water and land. And Bangladesh happens to be a delta country.
Looks like Vinay's internet cut out for a second there, so hopefully it pops back in. Okay. I assume he will join us as soon as he gets back on. I guess in the meantime, I could tell some water jokes or something like that.
Or is it worth maybe starting off with Dan, depending on how long Vinay is going to be?
Yeah, if it takes him longer than a minute, then
Yeah.
let's do that. But let's give him a chance here because I do feel like he's probably frantically trying to get it to start back up.
Right. You don't know any lighting jokes, David?
Well, you know what just came to mind is this is a joke that has a bit of a moral or a bit of an explanation behind it. So there's a kid and he comes running into his dad's into his house and he says, Dad, don't tell water. So someone's commenting, don't tell water jokes, you come off sounding like a big drip. Thank you, Mike. He comes running into his house and he says, Dad, there's water in the carburetor. What? Water in the carburetor? He's talking about his car. And he's like, oh no, the father's worried because it's their family car. No, Dad, there's water in the carburetor. Son, you don't even know anything about carburetors. How do you know there's water in the carburetor? He comes and says, no, trust me, Dad, there's water in the carburetor. He says, okay, whatever. I'll take a look at it. Where's the car? He says, it's in the pool. But the moral of that, the reason that one comes to mind is because it's kind of a, carburetors are the type of thing that it's old technology. What we like about carburetors is that we can work on them and everybody knows how to fix it. Not everybody. They used to know how to fix carburetors and get their car running and you can manually adjust things. Well, the new technology is much better. It's fuel injection, but you can't operate on your own fuel injector, and you essentially need to take it into a mechanic, or unless you're really skilled. Sometimes that's the way these new technologies are, and we have to find the balance between advanced technology that works better versus the older technology.
Hello.
More robust. Vinay, good to hear you again.
I'm back. I'm so sorry. I'm having some connectivity issues. But I think I'm gonna leave the video off and see if that helps.
Okay.
Let's try this again.
Let's do it.
So sorry about this.
It happens. No worries. I think the last 2 years have taught us all how to endure these glitches.
All right, let's fix this. Screen sharing. Oh. 1 second. Now I lost the whole presentation somehow.
Okay. We did have a suggestion, Vinay, if we wanted to let Daniel go, we could give you a little more time, but if you think you're close, then we'll just go with it.
I'm close. I'm gonna get this up here. Here we go. Okay, we're back.
Yes.
So did you catch my introduction?
Part of it cut off right where you were saying, talking about this aerial view of Bangladesh.
Oh, okay. So yeah, my wife is Bangladeshi and Bangladesh is a Delta country. So I wanted to just share on a personal note that, this view of the country, and what that means is it's a country that's below sea level. So this is a huge concern for Bangladesh. It's a country of 180 million people. And in the next 50 years, climate change is their #1 issue. So I think that just kind of brings it home in what we're talking about here. So the challenges. I think it's clear that we have a population that's growing. We have resource challenges when it comes to energy sources. And also we have a world that's becoming more digital. That's something that we recognize. And we also realize that lighting is going to grow. It has grown, and it's going to continue to grow from 2006 to 2030. There's going to be an increase of 35% in light points. So there's a huge role to play for lighting to address these challenges. And that's where LED comes in. So I think everyone may have a pretty good sense of LED at this point, but LED is a massive energy savings opportunity. And that can really be represented in the numbers seen here, where in 2006, global electrical consumption, for the lighting portion of that represented 19%. And that decreased to 13% in 2018. And we're projecting lighting's portion of electrical consumption to decline to 8% by 2030.
Well, that is,
Sorry, did you lose me again?
yeah, we did.
Oh, no.
And it went to mute. Did it stop screen sharing?
Yes. So
we might need to go ahead and proceed with Daniel's talk. Vinay, are you can you still hear me? All right, let's go ahead and proceed, and hopefully Vinay can get it worked out, and maybe we can have him show us a few things at the end. Daniel, would you be ready to dive in?
You bet.
All right,
Okay.
take it away.
My name is Daniel Hancock. I'm going to be presenting today the contractor perspective on the LED lighting. First, I want to thank you, David, and SCE3 and the Clemson Industrial Assessment Center for inviting me to be part of this today. So a little bit about me. I'm a proud Clemson graduate. Go Tigers. I'm a licensed engineer and general contractor. My company, I started my company 5.5 years ago at Super Green Solutions of Charleston. And we are mainly focused on LED lighting projects. And I'll get into why that is on the next slide. Some of our customers, recent customers include Clemson University. We did some solar street lighting for Clemson. City of Charleston, Mercedes-Benz vans is a real big project we're working on. Bosch, the U.S. Marine Corps, several school districts, and Habitat for Humanity. And to date, in the last 5.5 years, we've done about 150 total LED lighting retrofits. So not a big company, but very laser focused on energy efficiency projects. We're an advisor, supplier, and installer of energy efficiency solutions. So in addition to the LED lighting, some of the other focus areas include EV charging, which is coming on really strong right now, solar, indoor air quality, and energy management systems. So kind of a one-stop shop for energy efficiency solutions as a contractor. Now, I said I would explain why LED lighting is such a major part of my business. And I'm going to do that with why are our customers upgrading to LED? And this is my opinion of the reasons that we see for our customers upgrading to LED. And number one is to save money. We're reducing the wattage over traditional lighting by 50 to 70%. So that immediately translates into lower utility bills, saving money, improving the bottom line. So that's the number one reason, and it's the low-hanging fruit, which is why it's, as an energy efficiency company, why it's 90% of our business right now. Other than weatherization, it's probably the best bang for the buck ROI out there in energy savings. So it's really one of the first things companies look at, and rightfully so. Then the second reason is better lighting is needed. This can be for several reasons. It can be safety. There's code requirements for egress lighting that a lot of existing facilities don't meet. It could be that their tasks have changed in that facility. There's recommended lighting levels by the IES, Illuminating Engineering Society, based on what task is being conducted. Whether it's bulk warehousing needs 10-foot candles, office space needs about 30. A body shop needs 80-foot candles. So a lot of times we're coming in, to a facility to correct the lighting levels. The third reason better lighting is needed, a lot of places are just in disrepair. I'm in Charleston, we've got the old Navy base here. A lot of those facilities are just falling apart. And so we're redoing entire lighting systems. The third reason is a newer one over the last few years. It's to meet ESG goals, environmental, social, and governance goals. So there's a sustainability and environmental aspect to that. And again, LED lighting is one of the main ways to lower your consumption carbon footprint. So it's become a major driver of these projects. Fourth reason, reduced maintenance. Compared to traditional fluorescent lighting, LED has the lifespan is measured as an L70. L70 means how many hours it takes for the LED to output 70% of its original output. That's when it's considered end of life at the L70. And we're commonly seeing L70s of 200,000 hours now, which is just incredible. A fluorescent is measured as average lifespan, and it's about 10,000 hours. So, we can last 20 times as long as a traditional lighting solution. So that frees up, reduce maintenance. The electricians, maintenance techs, whatever, they get more important stuff to do than to be changing lights. So this allows them to focus on other more productive tasks. The last reason is to make money. This one, I think this should be the number one reason, but it's a lower, I guess, reason that people are coming to us. But in retail, better lighting directly equates into increased sales. If there's studies been done, you can see the product better, you're more likely to pick it up, and you're more likely to buy it. Manufacturing, better lighting, better quality control, office settings, better lighting can lead to more productive employees. So those are the reasons that we're dealing with mostly now. And now the up and coming reasons for the new technology and what's driving kind of the next generation of LED upgrades, retrofits. And I have a few reasons here. The adaptive lighting is a big one. It's adaptive lighting changes the color temperature throughout the day to match your circadian rhythm. A higher Kelvin temperature lighting is more like being outside in the sun. It actually changes your brain chemistry. Higher Kelvin temperature, it leads to increased cortisol, leads to more alertness. Lower Kelvin temperature, like sunset, the oranger light, will actually cause your brain chemistry to produce more melatonin, which is more calming. So good uses for the adaptive lighting technology, your retirement homes, daycare, offices. There's been studies in schools that show just by changing the lighting temperature, test scores go up because the students are more alert. So schools is another big one for adaptive lighting. A second kind of new reason for this advanced technology is COVID. The UV lighting is being integrated into the overhead lights to disinfect air and surfaces. So we've seen a lot of that over the last couple of years, schools and other areas. And the big one that I think is the main driver of the technology that Vinay will get into when he's back on is the 330-300 rule. And what that is, it's a general rule of thumb that says for every square foot of building or manufacturing, whatever, every square foot of a company's space, about $3 is spent on utility, about $30 is spent on rent, and about $300 per square foot is spent on the people in the building, on payroll, benefits, all that. So in the past, all we can touch with LED lighting is the $3, the utility savings. We didn't have any impact on the $30 rent, the $300 for payroll. With new smart lighting, we do, and building owners do. And I'll give a couple examples. So a rent savings, and this is a real example. There was a company, a building, an entire skyscraper in New York. They had smart lighting installed, and they were in the middle of making plans to expand to a new building. They had run out of space, but after they got the smart lighting installed, they used the data to determine that their conference rooms that they thought were booked, basically all the time, were vacant 70% of the time. So just from having that knowledge, that data, they determined not only did they not need to build this new building, but they actually had enough space left over once they got rid of the conference rooms weren't being used because they were on calendar, they were being used, but the calendar invites were old. So once they cleared off the calendar invites and everything and cleared that up, they ended up with an entire floor of empty space that they were able to lease out. So not only did they not have the capital expenditure, but they actually made profit by realizing that they had, by better utilizing their space with this data. The next solution is the payroll savings. So the rent savings, that's how we hit the $30. The payroll savings, how do we hit that $300? We make people more effective. So there was a study that found that nurses spend up to an hour per shift searching for equipment. So this smart lighting, overhead smart lighting technology, has the capability to integrate RTLS, which is real-time location services, and equipment tracking. Therefore, equipment, defibrillators, whatever, can be tagged and tracked, and they can use their tablets to real-time immediately locate equipment and not lose that hour a day searching for it. And the opportunities here are kind of endless if you think about it. You can geofence equipment or people. If a newborn goes outside of a defined area, it can lock the doors, notify the nurses, notify the authorities. So it's pretty neat stuff. So the contractor's role in an LED upgrade, I've broken it down in 10 steps. I'll get through these pretty quick. So number one is the consultation. And most of the time, the contractor is a lot of times the first point of contact for the customer. But it could also be an ESCO, an energy service company, as part of an ESPC, Energy Savings Performance Contract. Or it could be a lighting manufacturer's rep, like Vinay, or a lighting distributor. And at that stage, we're helping the customer to define the project goals, understand the needs, what are the pain points, budget, ROI expectations, and potentially discussing financing options. Then we have to audit the facility. That can be free as part of the project, or sometimes there's a cost to it. It averages about 3 cents per square foot. That's why the Clemson IAC Industrial Assessment Center, if a company qualifies, it's such a great opportunity because they provide that free of charge. But in the audit, you're surveying the facility, counting the lights, and we need to know what their output level is, how many watts the lights are. Number 3, we're gathering additional information, hours of operation, utility rates, etc. Number 4, we're designing the solution. This is where we're doing the photometrics based on recommended lighting levels for the task that's being completed. Number 5, we're presenting the solution, presenting the energy savings proposal, and discussing a project timeline with the customer. Number 6, customer signs proposal. Then we apply for rebates. An example of a utility rebate are here we have Dominion Energy, who has a 35 cent per watt reduced rebate for lighting projects. Number 8, project implementation. Typically it's a 50% deposit before we get started so that we can order materials. We install, commission, if controls are included, and recycle the old materials. The 9th step is a final site walk with the customer just to make sure everything is installed correctly to their satisfaction. And a lot of times we will take light level readings at this time to make sure that we hit the prescribed lighting levels for the tasks. Number 10, customer enjoys the new energy savings, reduced maintenance, and improved lighting. I've got a few case studies. These are real, these are actual customers of ours. This first one was an entire manufacturing facility. It was over 5,000 fixtures. It was a $1.1 million project with a 2.79-year payback, which is just phenomenal. Average savings over $400,000. And for this reason, the number one person when we're selling energy projects that we like to talk to is the CFO, because they understand the numbers and you just can't argue with these numbers. This is incredible annual savings. Number 2, or the second case study, is a warehouse, small warehouse, about a $90,000 project. Let me actually go back to case study 1. I forgot to mention something. On this large of a project also, you can see they had a $100,000 rebate from the utility company. That was a maxed out rebate. Very strong rebate. This second one, it was $90,000 net investment, 2-year payback, $46,000 annual savings. Just another great project. Here's a hotel. This was a large hotel, the entire back of house, plus all the common areas, but not including the rooms. It was a $124,000 project with a 2.5-year payback and $55,000 annual savings. Last one was a steel industry, just part of their facility. It was about a $200,000 project with, under sub 3-year payback, $67,000 annual savings. And the rest of the presentation is just some before and after photos. And I'll just give a brief description of what it is. This was a warehouse that had just been purchased. The top is the HID lighting. And the photos don't really do it justice, but you can see kind of in the background how dark it is and how many shadows over by the electrical panels. And the bottom is the LED upgrade. This is a parking lot in Columbia for an industrial facility. Just drastic improvement. The motivation here, they had so many lights that had failed. It was a safety concern for they ran 3 shifts, and for having the employees, going out to their vehicles at night, it was a safety concern. This was a warehouse in Myrtle Beach. It was fluorescent, mainly fluorescent conversion to LED. This was a relamp, which I didn't really get into in the presentation, but there's different ways to go about a LED upgrade. There's a relamp or a new fixture solution. Relamps are typically less expensive. We're using the existing fixture body and just putting new lamps in it. Normally a 4-foot TLED lamp. It can either use the existing ballast, or we put in a new driver, or we bypass the ballast. And the other option is new fixtures, more expensive, but often more reliable. That's the way we advise. This was a granite showroom. We've done a couple of these, and this is kind of an example of the retail, how an LED retrofit can help in a retail application. You can just see how much better you can see the slabs on the bottom photo. This was just a demo unit we put up. You can see the high pressure sodium lights in the back and the LED fixture in the front, just how much brighter, and then the color temperature. It's a whiter light. A body shop. This one was major improvement. The photo really doesn't do it justice, but we took this body shop from about 15-foot candles to about 85. So major improvement, much better quality control. This is another warehouse. Some more racking. You can see how much better the aisles are lit. Sports lighting. We've done a few sports lighting projects. The top fields were converted to LED, bottom fields were not. This was another relamp project. This is, I mentioned the Navy base down here. This was an old Navy base facility with fixtures that were in disrepair. And you can see that this was a really challenging project because that hangar is about 80 feet high. Another one from the Navy base. And this is an office space converted to LED flat panels. And this is an example of a solar street light. We did these for North Augusta, and a photo of those at night. Another warehouse, and that's it. Here's my contact info. If anyone needs to reach out or has any questions, feel free. And again, I'm gonna, Daniel Hancock with Super Green Solutions. I'm gonna hand it over, I believe, to Tim Howard at this time. And Tim is the facility manager for Clemson Watt Innovation Center. So take it away, Tim.
Can I interrupt a second? Tim,
Yes.
there's a question in the chat. So David, do we want to cover questions as they come up, or do we want to save questions to the end?
You know, since we just have one quick question so far, let's go ahead and address it now, maybe.
Sure. So Tom says, you may have covered already, are there HVAC savings when you switch to LED?
I did not cover that, but yes, that's a good point. There's major HVAC savings. Here in the South, we are mainly reducing the cooling that is required in the summer. So the cooling savings factor, we can save an additional 30% of the total project cost based on the new LEDs are not putting out as much heat into the space. So good question.
So the numbers that you showed with the return, that include the HVAC savings?
It did. Yes, those did.
Thanks.
Okay. Hello, everyone. Thank you, SCE3, for putting this on, and thanks for everyone here attending. I've got a few slides here I'd like to go through to put this in perspective. We're at the Watt Family Innovation Center in Clemson. My name is Tim Howard, and I'm talking here really, I was the project manager for the AV implementation within the building, but I'm really talking here about the director of CVAC operations and development and what that really is. So there's my contact information, and if you need to for later. Wanted to put it in, set up an agenda here. So I'm going to introduce you to the building to start with, and then look at some of the lighting. Talk a little bit more about the Energy Visualization Center and what we're doing. And hopefully by the time we've gone through all of that, I'll be able to show you some examples and you'll understand the context. So first of all, the Water Innovation Center. It was built in 2016. Gross square feet, it's over 76,000. It's 5 floors, 4 up, 1 down. On the front there, we have an LED display that looks pretty magnificent at night. It's 209 feet long and 24 feet high, and over 49,000 LEDs. And we've had to change a couple of them. The bird strikes and things like that, I think, I'm not sure. So inside, give you an idea of what it looks like. Here's the main foyer. I've done this for a couple of reasons. One, to show you one set of lighting that we have in the building, and those we have there, you can see can spotlights in that left picture. And in the right picture, room 106, that's what we've got in most of our classrooms, is a 2x2 LED light fixture. I would point out that all of our 2x2s are actually PoE plus. So there's no power up there. It's all being fed by an internet connection. We have an IP address for every single light we have in the building. That is that fixture type. And then looking down into that scope, really I wanted to show another type of lighting that we have, the pendant lamp there we have, to give you an idea of the lighting. So CVAC was started just under 3 years ago. It was to look at energy consumption, temperature, humidity, that type of thing within the Clemson University, using state-of-the-art equipment. CVAC is made up of 4 pillars, and the operations, research, industrial collaboration, and education is a big thing there. So what does that mean? Well, we get a group of students right now. We've had 32 students come through this program, and we analyze the data. Let's start at the very top, right? So we have a carbon neutral plan to be carbon neutral by 2030. And the light color is showing you what we need to do to achieve that. The dark color is really where we are. I would love to say that 2020 was because of projects that we've done, but unfortunately it's not. It was done because of COVID, but we're working towards that. And so the colors there, the light blue, the orange, and the dark blue, we're breaking up the scopes of carbon footprint. Yeah, and you'll see that purchase electricity is the orange. So it's a fairly large chunk, probably the largest chunk there, right, of our carbon footprint. So let's take that one step further and look at, well, where's that being used? We're monitoring 70 buildings at the moment on campus, and we can see which building is using the most energy, right? So we can pinpoint those, and there's a number of things we can then attempt to do, and one of them would be to bring in super green if we needed to reduce our lighting. But let's go down through this this process and see. So now we go down to the building level, right? So now we're looking at the building, and we can see the temperature, humidity, CO2. We can see how many people are in the building, and so on. Well, let's look at, so we're looking at there at the power consumption, 217. All right, well, that's good. Let's go down a little further. So now I'm looking at our sub-meters within the building, right? So what I'm actually trying to do is saying, well, where's my energy being used? And you can see there that right now the biggest contender of energy consumption is our HVAC systems, right? You can see it's beginning to drop down a little bit. We're making some changes there. Over the far right, you'll see that sort of purpley color dropping down a little bit lower than it has in the past. And that's through some AI work that we're doing to help reduce that. But down in that lower band, you'll see another kind of a purple line in amongst that green band, and that is our lighting. So let's drill down. You can put it in, I'm trying to show perspective, right? So where we are. So we're quite low down there, and that's because we're using LED lighting, right? That's the reason why it's down so low. So now we're zooming in now at our lighting. And we can see, where our lighting, which floor is using the most lighting. So here's the first tip of the day. With one of the differences for LED lighting, or at least PoE lighting, is it goes back to the switch, and the switch is located wherever. So if you want to actually understand which floor is using what power, then you need to make sure that the lighting panels are all lined up with the lighting of that floor. Remember, I showed you our main atrium, where in actual fact, right, the lights in the atrium were at the same level as the lights on the third floor. So guess what? They're all being fed back to the third floor panel, which is, that's what's causing that problem. So actually, no, sorry, the second floor, which is where the second floor is higher, is because it's taking up the second floor plus obviously some of the lighting of the atrium. So bear in mind that when you're wiring it all up. This is a retrofit for us, so we didn't, the meters were put in after, the sub meters were put in after. So go back. So now I can say, what floor, all right? And so now how do I drill down even further? Well, Signify provides you with the ability to then zoom in to say, okay, so now what am I using for my lighting, and by what room? So now I can see how much energy is being used by the lights within a particular room. And I can control the lights. I can set the dimming, the timeouts, that type of thing. And how long do I want the lights to stay on, right? And all that I can do within the Signify control panel. And here's an example of, all right, so, what is the light power being used within that room? And you can see there, it goes on. I showed you that it stays on for 10 minutes after people leave. So you can see that at 2 o'clock, the cleaners went in there, right? And did some work. We also have a get ready session with the AVs. The AV guys go in there at 7, make sure it's all working. And then students start arriving at 8. And then it goes through the rest of the day. And then by 4 o'clock, it's petering out. So that's you can understand there the usage of the room, right? And you can also make sure that the lighting is reacting accordingly. And you can see there that, our worst case, and we're well below 1 kilowatt of lighting. So that's pretty good. The media lights out the front. Here's a good example of the media lights. We were turning the lights off at night, but it's a bit like a computer system, and we were turning the display off, but not the computer system itself. And you can see that on the left there at September 2018, we weren't going much below 10 kilowatts, right? We worked with Signify and our installer and AV Design, and we put in a system. It cost us about $2,000 installed. And from then on, it's now running off of our Microsoft calendar. So we have an event to turn the media lights on when we're going to actually show content. And you can see now we drop down to 0.74 of a kilowatt. So huge savings for Christmas, holiday sessions, summer vacations and stuff like that. We've seen a huge thing, huge reduction. So that's the end of my slides. It was fairly quick. How's it going with questions?
Well, first I'll say that this is fabulous, Tim. And Daniel, appreciate what you had to say as well. So I think this is a good connection between installer and customer. I did want to see, okay, Vinay is ready to go. So let's try that out. And if others have questions, they can ask questions for anybody kind of at the end. let's try it here.
I'm here. Can you hear me?
Yes.
Okay, we'll give this another shot.
I'm going to go ahead and share my screen and we'll jump over to the slides. Yeah.
Okay. So I think we were on slide 4.
Slide 4. Okay, great. 3 right in here.
Yeah, so it's interesting because, you know, we were meant to peel back the layers of the onion and kind of go deeper and deeper. And you saw the depth and complexity of what Tim was just sharing. But, you know, setting back up this larger perspective, there's a huge benefit to LED. And that can be attributed to, you know, reduction in carbon emissions, about 1,400 million estimated per year at that 2030 mark. A save in energy costs that could be 272 billion euro by that 2030 mark, and reduction in power plants. That's 1,250 power plants you won't need any longer because of LED technology. If we could move to the next slide. So why LED? And wanted to just talk a little bit about the technology and what makes LED different. So we've heard, you know, about the energy efficiency versus incandescent. That's about an 80% reduction in energy versus fluorescent, 40 to 60% reduction in wattage used. And HID, surprisingly, you may know it's actually a very efficient technology, but HID has other challenges that are not represented necessarily by energy efficiency, but more in the lifetime of the lamp. So by the time you replace 2 to 5 HIDs, you could have used 1 LED in that lifetime. LEDs they operate very well in cold environments. They're smaller in size. They have new and unique form factors, and they're very easily controlled. Quick story here is when I started up in the lighting industry, I was always told with fluorescent lamps, when you install a new fluorescent lamp, you're supposed to let it burn for the first 2, 3, 4, 5 days. You're not supposed to turn that lamp off, because once you do, you're actually significantly reducing the lifetime of that lamp. LED doesn't have that issue. You can turn it off and on as many times as you like. It's not going to impact the lifetime of the lamp. LEDs turn right on. And another great benefit is there's no mercury, no UV or IR. Now, my favorite benefit, if you just hit the space or button here, is LEDs are fun. You know, I think we all have seen, especially in the pandemic time, a lot more of these wireless color changing LEDs that you can set up in your house and get better lighting for your Zoom calls. There's just so much you can do with them. Next slide, please. So I'm just going to gloss over this, but sustainability is really in Signify's DNA. If you look it up a little bit, Signify's been in the Dow Jones Sustainability Index for the last 5 years. We're top 1% in our industry when it comes to the sustainability metrics that are used by investors. And one big initiative for us is we're part of the Climate Pledge, and we're actually 100% carbon neutral as of 2020. So that was a really big deal for us. And one thing I also want to point out here is now that LEDs really taken a hold, we are focused also on connected lighting. And connected lighting, and you've seen it now, you've heard it from Daniel and from Tim, that's really the future of the technology. If you can please continue. So going beyond illumination is really the next step, versus just the energy efficiency story. The type of data that Tim just shared and the understanding and intelligence that you can get from having that sort of information is huge. And of course, with the cloud and connectivity, all of those lights can be tracked and monitored, and they can be also they can be leveraged into a network of sensors that collect data. And more than just how does lighting kind of illuminate a space, we're also thinking about how does lighting make a space safer? How does lighting make a space more comfortable? How does it make a space more energized and focused or entertaining, or bring some sort of value-added experience to the people in that space? And I'm going to continue talking about this here. If you can move to the next slide. You know, it's important, you know, to understand where we're going, where we've been. So this is just a quick look at kind of the progression of the technology and where we're headed. So of course, conventional lighting, it's been around for decades. That's your incandescent, your halogen, your fluorescent, your HID, and that really ruled the day for many decades. There was a time where halogen was the new thing, or HID was the new thing. In the early 2000s, there was a big shift to LED. That was around 2008. And that's really when it started to take hold of the market. And the biggest value proposition was the energy savings. So first you saw the halogens go, and you saw the incandescents get swapped out because those were easy to replace because of the energy savings. And now we're seeing a whole lot of fluorescent tubes also being swapped out for LED. And we're at a point here where we're more than 50% of the market is definitely headed towards LED. There's still quite a bit to go. And the US is lagging really behind Europe and Southeast Asia in the switch. But we're getting to a point where there are customers that made that switch 7-8 years ago. So what do they do now? And that's where we really talk about the lighting systems and services and the controllability of the lights, and whether do you really need a light to be full on when there's daylight in the space? Can you use a daylight sensor and reduce the amount of light you're outputting from a fixture? Can you reduce the light based off of occupancy? If you have a stairwell, does that light need to be full on while there's no one in the space? Can it reduce down to say 20%? So when you implement these controls and these energy saving strategies, you can gain an additional 30% of savings by leveraging those controls and those systems. And just hitting back on Daniel's point about the 330-300, where we're headed. So he already talked about the rule where this is looking at a per square foot metric. $3 per square foot goes to utilities. $30 per square foot goes towards a building and the rent and the efficiency of the building. $300 per square foot goes towards the people in the space. So what happens when everything is LED? We're going to have to figure out a way to impact that 300 and that 30 and bring lighting into the fold of being more value added, so that can we make a building more efficient using sensors with the lighting? Can we make a space more productive for people when you talk about scheduling conference rooms or floating working space? Though that type of environment? Can lighting play a role in that? That's what we're talking about as the future, and the data and the apps um, that can be connected with the lighting systems. So if you can continue, this is just putting a little bit of more meat on the bone in terms of the wireless control systems and the wireless lighting platforms that we have available and that are now becoming prevalent in the market. So it's really a tiered approach when you start looking at when do we want to go to some more advanced lighting control systems. The most basic, what we're calling foundation, is simple occupancy sensing, daylight harvesting, wireless switches, so you can put them anywhere without needing or requiring any power for them. And those are very simple and really standard offerings that gain code compliance and allow you to do the basic controls that you'd want with any fixtures in a space or lamps. And what you can then do is just add a gateway to that solution now, and you'll get the cloud connectivity, which would allow for a website interface, a dashboard, scheduling, those advanced dimming strategies, monitoring, and everything that you saw on Tim's dashboard. And also, demand response. So it's really just as simple as adding a gateway and having internet connectivity. The fixtures and the lamps, they all talk to each other using a Zigbee wireless controls platform. And then you're now in the world of data. But you can take it a step further with the enterprise system, and that really moves beyond energy saving strategies. That really is about, can we create an app for our office space? Can we create an app for our warehouse space that helps to optimize the work and the things that we're doing in that space? That's really what you start to talk about when you talk about an enterprise system. So you got your heat mapping, and you got people counting, and you got different sensors that are now connected to the lighting network, and allowing for some advanced features. If you can continue, please. So just going back to this 330-300 rule, on that, really basic illustration, that foundation is going to impact energy savings. The advanced, you're going to start talking about building efficiency, and enterprise, now we're talking about productivity and employee well-being and safety, the features that are enabled by data. Switching gears really quick here. So more than just talking about controls, as a manufacturer, we're also thinking about a circular economy. And that really is just about, how do we reuse resources? How do we limit the creation of new resources to support future products? So really quick example, if you can move to the next slide, of a new innovation that we're really bringing to market is 3D printed luminaires. And I think this is just something worth knowing about, because it's so new and it's very exciting. And these are actual photos of a 3D printing farm that we've set up in the US. We have 2 locations. Really cool stuff. It's, the product's made from recycled materials. When the product reaches end of life, it can be recycled and reused to make new fixtures. So if you can please continue. Really, understanding the circular economy and why sustainability is so important. One of the biggest things I'd like to point out here is you can see, by using 3D printed fixtures, you could achieve a 75% reduction in your carbon footprint compared to aluminum die-cast fixtures, which have been the standard for many, many years. So that's to me is a staggering number, and it's actually really impactful, just with the 3D printing, and the impact really comes from the materials that are used. Another interesting fact is they're lightweight, so there's a reduction in transportation cost, and at the end of life, those fixtures can be recycled and reused to make new fixtures. So just something fun and interesting to know about how lighting can be more sustainable. So this is really kind of was meant to lead into Daniel, but this is an opportunity here with looking at these new technologies and light sources to look at your space and think, is there a way to save energy, save money, get a return on investment, reduce carbon footprint, and all of those opportunities are available. And especially with rebates incentives now, it could be a really good thing to look at. And again, yeah, thinking about, I was meant to lead off here, but wanted to just quickly get you jump started on the whole lighting ecosystem and who's involved and how this process could work. And Tim, I hope you don't mind. Daniel, I hope you don't mind. I threw your photos in there just to kind of boost you up before your presentations, but we really have an ecosystem that works together as an end user, an owner, a facilities manager, energy manager, sustainability manager. When you're looking at projects, you can engage a number of different folks. You can engage Daniel, you can engage as a contractor, ESCO, an engineer, architect to consult and design solutions or review code compliance. As a manufacturer, we're going to be focused on manufacturing the product, developing new products, innovating, providing technical support and educating the market about the innovations we're coming out with. And of course, there's always distributors. They are taking that product and putting it into their pipeline. They're stocking it. They're providing logistics support and other support to customers. So there's a whole lot of folks that can help and help with the process. And hopefully this is something that you can look at and feel that it's informative and helpful. And that was it. That's all I had.
Thank you, Vinay. We made it through the technical difficulties, and by the end there, you and I were getting in sync to where I could predict when you wanted to move the slides. So that was great. Very good stuff. And I think these three talks really did paint a great picture. I think, for sustainability improvements, we need ecosystems of people working together. Are there any questions out there that folks would like to ask? Someone asked about sharing the slides, and I believe we talked about that possibility. Tim, Vinay, Daniel.
I can send you mine.
Okay, great. We'll get those out to everybody. And then a few people had to jump off because we did reach the top of the hour. But if anyone else has any questions, maybe we can stay on a few more minutes and try to entertain those.
There's a couple of questions in the question and answer boxes.
Oh yeah, go ahead. Could you read those, Beth?
Sure. The first one is, I think I'll just throw it out there and whoever thinks it's for them can answer. Are the light sensors, controllers, and software that Signify and Clemson use available for an existing facility to help manage lighting, or is a fixture replacement needed to allow for the sensors and controllers to be added?
I can take that one. So there is always the possibility to add a control system to an existing lighting system, it really depends on every situation. But that could at times also be cost prohibitive because of the type of wiring and I guess the labor that's involved with doing that. So there are now available in new fixtures and lamps this technology where you can look at it as a retrofit solution. There are something called retrofit kits that have sensors installed inside of them. So you would just replace an existing fixture with a retrofit kit, and that would also enable a potential control system. I think the best thing to do is reach out to your local support, whether it's an ESCO or a contractor or someone who can take a look at your existing infrastructure and maybe support you with what would be the best way to achieve the goals you're looking for, because it really does vary by specific applications.
It seems like it would be, I don't know if a shame is the right word, but in retrospect, if you went ahead and put in a control system for an existing lighting system, perhaps in order to incentivize people to realize some of the benefits, and then go back and try to retrofit to LEDs, I don't think it would be as cost effective.
Yeah, the conversion to LED actually subsidizes a lot of the cost when you add those advanced control systems. So that's the way we really look at it. The LED energy savings proposition itself gives back such a great return that when you're implementing that type of solution, it then becomes valuable since the lights are being replaced already, to think about for X%, like a small adder, what other solutions could be enabled. So that's really how people are looking at that.
So there's one other question. Are we saying there are no consequences from using LEDs?
I guess I'd need to take that one offline and try to understand better what the
Question is asking.
Yeah, what the question's asking.
There are two things I can think of, the raw materials for LEDs versus others. And then one of the things that kind of concerns me is light pollution. So if you can light better and more and cheaper, then people will maybe tend to light more. But I think one of the things that you've said is the technology to turn the lights off or dial them back when they're not needed. So that should be a bit of a compensation there. But the materials issue could be real.
Yeah. Yeah, I wouldn't know how to answer that right off the bat, but the whole thing about light pollution, I could say that LEDs are directional. So when you talk about street lighting, one great thing about them is there is no spillage. So it really contributes to a dark sky initiative. I would encourage folks to look at LA before and after LED conversion. It's really incredible. There was so much light spilling upward prior to LEDs, and it really kind of had you could see the darker sky and you could see the stars. So it really that's a very interesting thing to look at. But in terms of recycling, I mean, I think fluorescence also had challenges with recycling, And I think that's something maybe Daniel could even talk about more, is how he recycles, you know, older generation LED products.
Yeah, I could just comment on it real quick. I mean, we have to send the tubes away as hazardous material before we have to have them tested in order to have them not be hazardous, because they contain mercury. So, I mean, in that respect, it's a cleaner technology. It still has, some metals that it uses that I'm sure is going to have its recycling challenges, but certainly cleaner than the older technology.
Very good. Well, I could imagine we could go through a lot more questions, but we probably better go ahead and wrap up now. Thank you, Daniel. Thank you, Vinay. Thank you, Tim. Appreciate these presentations. And as was mentioned in the chat, we'll share. Well, actually, we're going to share two things. We're going to share just the recording for the webinar, and you can go back and look at that. But we'll also send a separate email out to share slides. Any last comments that any of the panelists want to say before we sign off? Okay. Well, thank you. And thank you for all those who attended and were with us today. Have a great rest of your afternoon.
Thank you.